For decades, the survival of a tank on the battlefield depended on two things: thick armor to stop bullets and shells, and explosive reactive armor to defeat older anti-tank missiles. But modern threats have evolved dramatically. Today, a multi-million-dollar tank can be destroyed by a single soldier with a top-attack missile like the Javelin that strikes from above, or a high-speed rocket from kilometers away. This vulnerability demanded a revolution in defense, not just stronger armor, but a system that could actively intercept and destroy incoming threats before they even hit. This is the world of active protection systems, or APS, the invisible shield. In this video, we'll break down how these high-tech systems work, examine the leading APS like Israel's Trophy and Russia's Afghanit, reveal their surprising Cold War origins, and see how they are performing in the ultimate testing ground, the war in Ukraine. An active protection system isn't a single piece of hardware. It's a complex, automated sequence of events that happens in milliseconds. Think of it as a three-step kill chain that must be perfect every time. Number 1. Detection. The system uses sophisticated radar arrays, typically one on each side of the turret, constantly scanning 360 degrees around the vehicle. This radar isn't just looking for objects. It's specifically designed to detect the unique signature of an incoming threat, whether it's a slow-moving RPG or a hypersonic anti-tank missile traveling over 1,700 meters per second. Advanced signal processing instantly calculates its speed, trajectory, and point of impact. Number 2. Tracking and targeting. Once a threat is detected, high-speed computers analyze the radar data. They determine the precise point of impact and decide on the optimal moment to intercept. This calculation is incredibly precise. Firing too early might miss the target, while firing too late allows the threat to get too close, potentially causing damage even if destroyed. Some systems also incorporate electro-optical sensors to visually confirm the threat type. Number 3. Countermeasure. This is the active part. The system launches a countermeasure to neutralize the threat at a safe distance, typically 10 to 30 meters from the vehicle. There are two primary methods. Hard kill. This involves physically destroying the incoming round. It typically fires a small, focused projectile or a shotgun-like blast of tungsten pellets to smash the threat mid-air. The intercept angle is precisely calculated to ensure the blast pattern intersects with the threat's path. Soft kill. These systems don't destroy the threat, but confuse or disable its guidance. They might use lasers to dazzle the missile's infrared seeker, deploy multispectral smoke screens to break laser locks, or even emit radio frequency jammers to disrupt missile guidance signals. For defending against high-speed, kinetic threats like missiles and RPGs, hard kill systems have become the gold standard because they physically eliminate the danger rather than just trying to deceive it. Several nations have developed advanced APS, but a few stand out as the most battle-tested and technologically advanced. Israel's Trophy system, developed by Rafael, is the most proven APS in the world. It's a hard-kill system providing 360-degree protection. What makes Trophy exceptional is its sophisticated threat classification. It can distinguish between actual threats and false positives like birds or debris. When it detects a real threat, it fires a small, focused charge of metal pellets that destroy it with remarkable precision. Trophy has been operational with the Israeli Defense Forces since 2011 and has successfully intercepted numerous RPGs and anti-tank missiles in real combat, including during operations in Gaza. The U.S. Army has taken note and is now integrating Trophy onto its M1 Abrams tanks, designating it as the Trophy HV system. Russia has developed several APS. The older Arena system is similar to Trophy, but has seen limited service. Their most advanced system is Afghanit, designed for the new T-14 Armata tank. Afghanit is claimed to be a comprehensive system that uses both hard-kill interceptors and soft-kill measures, with the extraordinary claimed capability to intercept armor-piercing, fin-stabilized, discarding Sabot tank shells, the fastest and most difficult threats to stop, traveling at over 1,700 meters per second. However, the T-14 Armata has not been deployed en masse, and evidence of Afghanit's real-world performance remains scarce. The system's actual capabilities against the full spectrum of modern threats remains somewhat speculative. Other nations are rapidly developing their own systems. Germany's Aktivdeckungssystem, which translates from German to active defense system, uses a directed fragmentation warhead for interception. South Korea's Iron Fist, which has been exported to several countries, uses a vertically launched interceptor ideal for top attack protection. Even Ukraine has developed its own system called Zaslin. This global proliferation shows that APS is no longer a luxury, but becoming standard equipment for modern armored vehicles. The war in Ukraine has been a brutal laboratory for modern weaponry, particularly for tank survival systems. So, how have active protection systems performed? The reality is their presence has been surprisingly limited. Despite Russia having systems like Arena and Afghanit, there is little verifiable evidence of them being widely deployed on tanks in Ukraine. The vast majority of Russian tanks lack any advanced APS. Why has this high-tech solution been largely absent from such a high-intensity armor conflict? There are several compelling reasons: cost and complexity. A single trophy system costs approximately $300,000 to $500,000 per vehicle. Equipping thousands of tanks represents a massive financial investment. Maintenance and training. These are sophisticated electronic systems that require expert maintenance and specialized training for crews, both challenging in a high-intensity war of attrition. Risk to infantry. Perhaps the most significant tactical concern, a hard kill system detonates an explosive charge near the tank, which can be lethal for any friendly infantry soldiers operating within 50 to 100 meters, severely complicating combined arms operations. Instead, we've seen the crude, widespread use of cope cages, slat armor added to tank turrets in a desperate attempt to defeat top-attack drones and missiles. These are a stark contrast to high-tech APS and highlight the critical vulnerability that APS is designed to solve. On the Ukrainian side, there have been notable instances where Western-supplied vehicles like the Bradley fighting vehicle have survived seemingly direct hits from RPGs. While most Bradleys don't have dedicated APS, these events demonstrate the value of integrated survivability suites and spaced armor. The conflict has overwhelmingly proven the need for APS, even if the systems themselves are not yet commonplace on the battlefield. The sheer volume of anti-tank weapons, from expensive missiles to cheap FPV drones, has created an environment where traditional armor alone is increasingly inadequate. Despite their potential, APS face significant challenges beyond just cost. The primary tactical issue remains the danger to dismounted infantry. The explosive countermeasure of a hard-kill system creates a lethal radius around the tank, making it risky for soldiers to advance alongside it, a fundamental part of combined arms tactics. Future systems are addressing this with more precise, directed energy interceptors and non-explosive technologies. The U.S. Army's Leonidas system, for example, uses high-power microwaves to disable the electronics of incoming threats en masse, particularly effective against drone swarms. Speaking of drones, the proliferation of low-cost unmanned aerial vehicles represents both a challenge and an opportunity for APS. Current systems struggle with swarms of multiple small, slow-moving drones because they're designed for fewer, faster threats. Next-generation APS will need to handle these saturation attacks. Perhaps most intriguingly, the concept of APS isn't new. The Soviet Union developed the Drozd system in the 1970s, and work on these technologies dates back to the 1950s. What's changed is that the technology has finally matured to the point where it's reliable enough for battlefield use. But the trend is clear. As anti-tank weapons become smarter, faster, cheaper, and more ubiquitous, passive armor alone is no longer enough. The future of armored warfare will be a high-speed electronic duel measured in milliseconds. The vehicle that detects, processes, and intercepts first will survive. The one that relies only on its armor will not. A PS is evolving from an optional accessory to an essential component of battlefield survival. Active protection systems represent a paradigm shift in military technology, moving from purely passive defense to active interception. They are not a perfect shield. No system is invincible, but they are becoming a critical layer in the multi-layered survival strategy for modern armored vehicles. From their Cold War origins to their limited but revealing performance in Ukraine, The invisible shield has proven itself as an essential part of the 21st century battlefield. If you want to see more cutting-edge military technology explained, make sure to like, subscribe, and hit the notification bell. Let us know in the comments which military technology you'd like us to cover next. Thanks for watching.